Excuse me? Excuse me? I don't see the note.
You don't have any note on the slide.
No, okay.
Yes, the next slide is that.
Ladies and gentlemen, good afternoon. This lecture is a little different. It is kind of a memorial to Dr. Limor, my colleagues, David colleagues, RL colleagues. Limor passed away suddenly a few weeks ago at the age of 55. Limor led this research and prepared this presentation for the conference, and I will be in honor to try and present it. The methodological approach of this study consists of three parts. Part one is a background to the study, including a literature review, climatic data from representative meteorological station in the city of Tel Aviv, parameterization at the site, and a social study. The second part is a UHI mitigation study by measurement and simulation to identify the hotspot at the site and modeling the current situation and modeling another three scenarios, and finally forecasting tools. So if we're talking about Tel Aviv, we have a problem with the meteorological station because we don't have a meteorological station within the city. The two meteorological stations are A and B, located at the coastline, and the third, C, is actually a Palmachim Meteorological Station, which represent the best control rural station to characterize the UHI in the city of Tel Aviv. When we are looking on climatic change and urban warming in Tel Aviv since 1964 to 2019, one can see the temperature have been changed, mainly minimum temperature at night during the summer and the extreme events. Firstly, we investigated the relation between the surface UHI and NDVDI, and they showed that the hotspot of Tel Aviv are located at the south of the city, which are lacking of vegetation. And we try to analyze it with the LCZ. One can see that this area, the south area of Tel Aviv, is also the most dense part of the city, including LCZ2 and LCZ3. By the way, the hot spot at the north of the city, it's the Tel Aviv airport. The slide shows research by the municipality of Tel Aviv, which combine the heat map of Tel Aviv with socio-economic characteristic of the population. And it's revealed that the most vulnerable population live in the hottest place in the city. After Shapira neighborhood was identified as the hotspot, as shown in the LST and NDVI mapping, the municipality of Tel Aviv decided to reconfigure the neighborhood as part of making Tel Aviv as a climatic resilient city. The Shapira neighborhood, located 1 kilometer from the sea, average height of 30 meters above sea level, contain mainly buildings of 1 to 3 floors. The morphological structure of the neighborhood is orthogonal, and the neighborhood is being redesigned for expansion and densification. And as we said before, the socioeconomic level is low, and the neighborhood is facing a developing process. That's make the physical data of the neighborhood an ideal in terms of modeling and forecasting scenario for urban heat island mitigation. The pictures show the typical road in the neighborhood, quite old, low buildings, and in the center of the neighborhood there is urban park, or let's say urban garden, which is quite interesting to see what it can be done to the city. So we try to mitigate the urban heat island of Tel Aviv as well as Shapira neighborhood by meteorological station and by mobile measurements and by thermal images of street segments. And in the measurement campaign that was done during 2021 to June 2019, measurements were taken in the street, in each street, each represented street, fixed meteorological station were posed, and along the street mobile measurements were taken. The Shapira neighborhood experienced a daily UHI of 3 degrees and nocturnal UHI of 4 degrees, where the west-east orientated streets are hotter by 1 to 2 degrees than the north-south orientated streets. And looking at the mobile measurements show that the midday, the urban park, is up to 3 degrees cooler than the street around it. However, when we try to look at the thermal sensation, one can see that in terms of PET, the urban park is 15 degrees cooler than the streets, which make the streets to be very hot and the park slightly warm. The above map was impetus for a further study, a simulation of the effect of walls, pavement, asphalt, surface, roof, and surface under the trees. And as one can see, we took thermal images of the street segment in order to study the walls effect, the wall temperature, and their effect in each orientated street, the asphalt temperature under the trees, different type of roofs inside the neighborhood. All these results can be seen in our paper, Urban Spatial Pattern and Heat Exposure in the Mediterranean City of Tel Aviv, led by Moshe Mendelmich. So the next step was UHI mitigation study by simulation. The work was based on a former work of Limor, and what she tried is to demonstration of regression-based forecasting tool that was developed for LCZ3 in Tel Aviv according to street morphology and tree covers. She took 3 forms of separated form, continuance form, and colonnade form, studied their effect on air temperature in the street, and then for climatic scenario in the simulated streets in Shapira neighborhood were done using the Green CTT model. We took the existing situation and then we planted trees inside the street. We increased number of floors to 4 floors, and the last stage was combined scenario with a colonnade and trees. So what we can see in the simulation. First of all, if we take the 4 floors above the existing situation of 1 to 3 floors, we can see increase of almost 2 degrees. Then, if we take the existing situation, the scenario, and we plant a tree in the 4 floors scenario, we can reduce temperature up to 4 degrees during daytime. But in the last stage, when we added or when we designed the street with colonnade, then we can reduce temperature by 5 degrees during summer day. The next step was to study a scenario for the predicted climatic changes. The simulation were done by the Columbia University, and we used this simulation that was general to the city of Tel Aviv for the scenario of 4 floors according to 2 scenarios of Columbia University, and we found out that in the year 2050, street can be warmer up to 4 degrees in the higher scenario. In the final step, we try to draw a map using the ENVI-MET software and to show the special pattern of temperature inside the neighborhood, in different parts of the neighborhood and in the urban area and in the urban park. So the conclusion are that urban renewal can be an opportunity for climatic rehabilitation of poor area. Climatic rehabilitation can be done by planting tree along street, planting an appropriate relation between high and wide ratio of the street, and by construction of colonnade along the street. And in area of climatic change and global warming, proper adaptation of urban design is required in order to create a resilient city. Thank you very much.
Any more questions from audience? Yes, please.